Have you ever wondered what happens when a star dies? It's a question that has sparked curiosity and intrigue for centuries. Stars, much like living organisms, have a life cycle. They are born, they live, and eventually they die. But unlike most living creatures, a star's demise can give rise to one of the most enigmatic phenomena in the universe, a black hole. Black holes are the remnants of dead stars. After a star exhausts its fuel, it collapses under its own gravity, creating a region in space where gravity becomes so incredibly strong that nothing, not even light, can escape. That's right, black holes are so powerful that they imprison the fastest thing in the universe, light itself. Imagine the universe as a vast cosmic ocean. A black hole would be like a whirlpool, a place where the water, or in this case space, is moving so quickly and so violently that nothing can swim against the current. It's an abyss, a point of no return. But black holes are not just cosmic vacuums, sucking up everything in their path. They are also shrouded in mystery and paradox. For instance, while we call them black holes, they are not truly black in the conventional sense. Rather, they are invisible, their existence only inferred by the effects they have on their surroundings. Despite their invisibility, black holes have a profound impact on the universe. They can warp the fabric of space-time, bend light around them, and even influence the behavior of nearby galaxies. They are cosmic powerhouses, engines of creation and destruction. Yet, for all their power and influence, black holes remain largely misunderstood. Their properties challenge our understanding of physics, pushing the boundaries of what we know and what we can imagine. So if black holes are invisible, how do we know they exist? This question takes us to the next stage of our journey, where we will explore the techniques scientists use to detect these unseen, unimaginable forces of the universe. Stay tuned as we delve deeper into the enigma of the universe, the black hole. Black holes might be invisible, but they leave a trace that we can detect. Now that might sound like a riddle, but it's actually a fundamental principle of astrophysics. You see, even though black holes themselves are invisible, they have a profound influence on their surroundings, and it's this influence that gives them away. For instance, when a black hole is near a star, it can start pulling on the star with its immense gravitational pull. This can cause the star to move in a way that's different from what we'd expect if the black hole weren't there. Scientists can observe this unusual movement and deduce the presence of a black hole. But stars aren't the only things that can reveal a black hole's presence. Gas, too, can give them away. As a black hole pulls in gas from its surroundings, the gas forms a swirling disk around the black hole. This disk gets heated up to incredibly high temperatures, causing it to glow brightly. And even though we can't see the black hole itself, we can see this bright disk of gas. But there's another, even more fascinating way that scientists can detect black holes: gravitational waves. These are ripples in the fabric of space-time itself, caused by the movement of massive objects like black holes. In 2016, scientists made the first ever direct observation of gravitational waves, confirming a prediction made by Albert Einstein a century earlier. This was a monumental achievement in our understanding of the universe, and it opened up a whole new way for us to study black holes. So even though we can't see black holes directly, we've developed ingenious ways to detect their presence. Through careful observation and a bit of clever deduction, we can uncover these invisible behemoths lurking in the depths of space. Now let's dive into what happens inside a black hole. Imagine being able to travel inside a black hole. What would you find? As we plunge into the enigmatic abyss of a black hole, we're venturing into the realm of the unknown, a place where our understanding of physics is stretched to its limits. The center of a black hole, known as the singularity, is a point of infinite density. It's the heart of the black hole, where matter is crushed into an infinitesimally small point. Our understanding of what exactly happens here is still shrouded in mystery. The laws of physics as we know them simply cease to apply. Now let's talk about a rather peculiar phenomenon that occurs as you approach a black hole: spaghettification. Picture this. You're being pulled into a black hole feet first. The gravitational pull at your feet is stronger than at your head, so you begin to stretch. The difference in gravitational pull is so great that you become elongated, like a piece of spaghetti. This is spaghettification in action. It's an extreme example of the tidal forces that drive our ocean's tides, but cranked up to an unimaginable degree. But here's the thing. Despite their fearsome reputation, black holes aren't just cosmic vacuum cleaners indiscriminately sucking up everything in their path. They're actually quite selective. Only objects that venture too close get drawn in. And once inside, well, that's a one-way trip. There's no coming back. Black holes are incredibly dense, with gravity so strong that not even light can escape their grasp. But they're not just about destruction. Black holes are also creators. They're thought to be key players in the formation of galaxies, including our own Milky Way. They recycle matter and energy, and as they feast on the surrounding gas and dust, they can trigger the birth of new stars. So while black holes may be the ultimate symbols of cosmic doom, they're also the architects of the cosmos. They're a testament to the yin and yang of the universe, the delicate balance between creation and destruction. But black holes aren't just about destruction, they also play a crucial role in our universe. Black holes are like the vacuum cleaners of the universe, but they also have a constructive side. Let's dive into the role of black holes in galaxy formation. Picture a galaxy. It's a whirlpool of stars, gas, and dust, all swirling together in a beautiful cosmic ballet. But at the heart of this dance, sitting in the orchestra pit, is a supermassive black hole. These supermassive black holes are not just bystanders, they're the conductors of the galactic symphony. They're called supermassive for a reason. They're millions to billions of times more massive than our sun, and they have a significant influence on their galactic neighborhood. So, how do black holes aid in galaxy formation? Well, it all starts with a vast cloud of gas in the early universe. Gravity pulls the gas together, and as it collapses under its own weight, it begins to spin. At the center of this spin, a black hole forms. The black hole then grows by gobbling up matter from around it. As the black hole feasts, it builds up an accretion disk. This is a ring of gas and dust that spirals into the black hole, like water going down a drain. The intense gravitational pull of the black hole and the friction within the accretion disk generates enormous amounts of heat and light. This light in turn pushes outwards, driving the remaining gas away from the center of the galaxy. And here's where the black hole's role becomes crucial. The expulsion of gas prevents the formation of new stars in the galaxy's core, effectively regulating the growth of the galaxy. It's a cosmic balancing act, with the black hole acting as the fulcrum. So far from being just galactic destroyers, black holes are also creators and regulators. They are the cosmic architects that help shape galaxies, including our own Milky Way. So, are black holes a threat to us? Should we be worried about black holes? This is a question that's often asked, and the answer is a resounding no. The reason for this is simple. The nearest black hole is thousands of light years away. To put that into perspective, 1 light year is about 6 trillion miles. So when we say thousands of light years, we're talking about a distance so vast it's difficult to truly comprehend. Now, that's not to say black holes aren't powerful. They are. In fact, their gravitational pull is so strong that nothing, not even light, can escape once it crosses the event horizon. But their reach is not infinite. Unless we were to find ourselves dangerously close to a black hole, which is highly unlikely given the distances we're discussing, we would be safe from its effects. So, if they are no threat, why do we spend so much time talking about them? Well, apart from being one of the most intriguing phenomena in the universe, black holes could potentially play a key role in future space travel. Some scientists theorize that black holes could act as shortcuts through space, a concept often referred to as a wormhole. While this is purely theoretical and the practical challenges are enormous, it's a tantalizing thought. Imagine being able to traverse vast distances in the blink of an eye. It's the stuff of science fiction, but then again, so was landing on the moon once upon a time. So, black holes, once thought of as monstrous destructive forces, are actually fascinating and essential parts of our universe. They continue to captivate us with their mystery and might as we strive to unravel their secrets. Black holes are not something to fear, but to study, to marvel at, and perhaps one day to use as stepping stones in our journey through the cosmos.